I thought I would not be able to record the lecture, but I think we should be able to do it. Okay, so last time I think we finished to solve the problem of the two cells, no? Like we have like a box with two different cells. And okay, so today we're going to start something not new, but we're going to do the same thing. So today, let's say I'm first going to redo a very quick derivation, which is shear flow. In a curvilinear member. Okay, so I think that I already showed you the equation. I think you are familiar. It's something you should have done in structures 1. So let's say we have a curvilinear member like this. So the center will be right here at point O. Let's do here the perpendicular. So any radius will be perpendicular. Let's say that what we want to do is to find the shear flow over here. Q12. So if I call this 1,2, this should be 0.1, this should be 0.2. Okay. So again, this is not that important. So let's say we're going to start going from here. So let's say we know the shear flow over here at Q1, let's say 0. All right, so what can we do here? So let's say we're going to apply a moment over here. And about point O. I do one more thing on the figure and then we start the derivation. We take a little piece of, or a little slice of this circle. I'm going to say this is the area dA, and that little section here will be, maybe let me put it here, this will be, so this is S, this will be ds over here. That little segment over here. And last and not least, this distance over here, the perpendicular distance or the radius, let's call it P instead of R. Okay, so let's say that this little piece here is small enough. So if it's small enough, we could assume that this little piece over here will be almost a triangle. No? So what will be the area of the triangle? Should be height against base divided by 2. Okay, again, the derivation is not important, so don't worry about it. So basically, this is going to give you that to dA equal to P ds. Or if I integrate over here, this basically will yield to say that 2A is equal to the integral between 1 and 2 of P ds. Okay, I don't know if you did the derivation or not. Again, the derivation is not that important again. It's just the final equation. Not this one, okay? We're not there yet. So if we take moments about point O, okay, doesn't matter how we do it, but let's say counterclockwise. So let's see. This will give you what? Moment M, which is this here about point O. Then what will be the moment created by the shear flow? Will be minus Q12, no? But what is the value of the force over here? Should be Q12 ds integrated over here times the arm P. So if you want, this will be force this is the arm, okay, or the moment. This should be equal to 0. So basically, I can write over here that M. I can just write this a bit differently. I can say this will be equal to, let's see, Q12 integral of PDS. Yep.
Wasn't Q12 supposed to be negative? Because it's going clockwise.
Yeah, I put negative here.
Oh, so I think that's equal.
No, it was over here. So basically now I'm doing all this stuff for what? What did we just over here is that this term over here, and let me put it here on the side, and we know that integral 1 to PDS is equal to what? 2a. So basically, this gives you that the moment created by a shear force or a shear flow around a curvilinear member will be equal to what? 2a Q12. Okay? So I don't know if you derive the equation in structures 1, but basically, I'm sure you have seen that equation before. See if I can remove that stuff over here. Yes.
What did you write there of those two floors?
Arm. Okay, so let's do one example. So in this example, the structure will be a one cell member. Okay, for this we're gonna have here stringers or stiffeners, and on the panels here, here, and here. So let's say this would be 1, 2, 3, 4, 5, 6. Okay, and let's say that the curvilinear side has a radius r. Okay, in this case over here, we have a shear force Vy equal to 10,000 pounds that is acting at a distance s from the right edge of this cross section. Okay, so over here, some data is that s will be 8 inches. Then we can say that all members have all panels, let's say all panels better than members. Okay, we write it all panels have the same thickness. And assume on this problem, assume skin not effective. So basically, I don't have the equation, but remember we said the same thing. That long equation that I gave you had one of the terms. Oh, I still have the equation here. So yeah. Okay, we need some more data. So the more data will be B1 equal B6 equal to 1 inch square. So B1, B6, B2 equal to B5 equal to 0.5 inch square. And then we're going to have B3 equal to B4 equal to 0.5 inch square. Okay, and then all the other distances, so let's say S12, S23 equal S45 equal S56. And equal S61 equal to 10 inches. And the radius R is 5 inches. Basically, we know what's going to be fine. Yes?
Can you please do it? Thank you.
Yep. Okay, so again, same thing as we did last time. Let's try to follow the procedure. Step one, what is step one that we did last time? What is it?
Make them flat.
Why do we need to make a cut? What was the reason? Correct. So you need to make a cut somewhere so you know the shear enough where to stop. Okay. All right. So here we go. So let's make a cut over here. We can do it anywhere you want, but we're gonna make it here right on the circular place. Okay, because it's gonna be make it a little bit easier. So let's say I have this. Yeah, so let's say I make a cut somewhere there. Okay, so if I make a cut over there, what does that mean for Q34? Q34 will be 0. Okay. And as before, the shear equation for Vx equals 0 and symmetric cross section. So we have a symmetric cross section. We had the same thing last time. That means that the polar moment of inertia x y is equal to 0. So the equation here Q of S becomes minus Vy divided by xx. Sorry. Thank you. And then we have over here the two terms. One is 0 to ST YDS plus the summations here of R equal to 1 to 6 B sub R Y sub R. So same as the example of last time. What do we see on the example last time? All panels have the same thickness and assume skin not effective. So if we assume the skin not effective, what does that mean about this term? We say that is 0 because we assume that T is 0, no? In resistance shear. So we assume that all the shear is resisted by what? By the booms, no? Or the stiffness. Okay? 1 through 6, correct? Okay. Okay, I'm going to add here one thing that I will discuss it later, but just so that when you look at your notes, you know what type of problem is this one. But over here, this is a problem which is statically determined. Yes. Okay, so that is statically determined. What does it mean? What does that mean mathematically? Or from the engineering point of view? Is that you should be able to solve it only by using the equations of equilibrium. Okay, so let's see what happened. Okay, so make a cut. So what do we make the cut? So basically here, let's write down the equation that simplifies. This simplifies to Q sub S equal to minus Vy over Ixx summations of the B sub R, Y sub R are equal to 1 to 6. Okay, where in this equation, we also did it the other day. What is Ixx? What is Ixx? What is it? Is the area moment of inertia. What does that mean physically? Okay, I'm going to ask you all this stuff on the exam then. What is I? What is this stuff? And then, the stuff. What is the physical meaning of the moment of inertia? So you said last time twice. So it's the resistance to rotation, no? Okay, all right. So in this case, and this is about when you find this, since this is symmetric, this will be right in the middle. Let's say this would be Y. So what would be the moment of inertia equal to? Will be equal, so let's see. Let's call that distance here H, okay? To simplify the stuff. So this will be H, no? I mean, let's do it. So what will be the moment of inertia? What is the expression for the moment of inertia is Y squared dA. So this will give you what? Should be equal to what? B1 Y1 squared, that will be equal to what? H squared, no? Plus what? B2 H2 squared plus B3 H squared plus B4 minus H squared plus B5 minus H squared plus B6 minus H squared. So in this equation, what will be H? H is 5, no? So if we do the math, this will give you a moment of inertia, believe it or not, lucky, just equal to 100 And what should be the units? Inches to the 4, because we have area, units of area times y squared, no? Okay? Okay, so basically, let's go now to this equation. Now using here, we can go out. So let's start by Q34. We know that Q34 is equal to 0. So next we can do what? Q45 will be equal to what? What will be Q45? Q45 will be Q34 minus Vy over Xx times what? We go from 0.4 to 0.5, so that will be before Y4, no? Okay, so if I just do this one now very quick, this will give you 0 minus 10,000 divided by 100. What is before? From the initial data? 0.5. And what will be Y4? Is -5, correct. So if you do the math for this is going to give you here 250. Okay, so we do the same thing. So then Q56 should be equal to what? Q45 minus Vy over Ixx B5 Y5 equals to 250 minus 10,000 over 100 times what is B5? 0.5 as well. And what would be Y5? -5. So basically we get exactly the same thing as before, but twice. So this will be equal to 500. Okay, next we do Q61. So Q61 will be equal to what? Q56 minus Vy over Ixx B6 Y6. So this is equal to what? 500 minus 10,000 over 100. What is the value of B6? One. What will be the value of Y6? -5. So this one should be the double as the other one. So again 500. So 500 plus 500 will be equal to 1,000. All right, so we go around. Now Q12 will be equal to what? Q61 minus Vy over Ixx B1 Y of 1. Q61 is equal to 1,000 minus 10,000 over 100. What is B1? 1. What would be Y1? Would be 5, because the one on top, okay, is the one here. Okay, so we'll be positive 5. So basically that means that we're gonna have what? The 1,000 minus 500. This should give you 400. Okay, so finally we need to do 3 equal to Q12 minus Vy over Ixx B2Y2. So this should be equal to what? 500 minus 10,000 over 100. What is B2? 1.5. What would be Y2? 5. So this would be again minus 250. So this one should give you what? 250. But does that make sense at all? I mean, if you look at it, these two should be the same, no? They are symmetric. So they are Q23. What do you have for Q23? 250. What do you have for Q45? 250, no? What do we have for Q56? 500. Q12, 500. Yep. Okay. I mean, we do the complicated. We could do this almost by logic. Okay. And at the end, okay, we know Q34 is 0. So all these steps over here make them tough. And applying this equation, okay, this equation here is similar to do if you want mentally, okay, it's not exactly the same, but this is, I mean, it is exactly the same, but this is similar as doing summation of forces equal to 0, okay? All right, so we know that a statically determinate system, we should be able to solve it by only doing the static equations. Okay, so let's follow the procedure again. So we finished step 1. If we look at the notes from last time, what was step 2? Okay, we have the 2 bars, no? Is that what you're saying? But what pattern did I put on step 2? I said evaluate shear force? Yeah? Okay, so evaluate. Okay, so basically now what we do is that we close the structure. Okay, and because we close it, now we know we're gonna have some constant shear flow being applied over here. Okay. So if you want, we do as before, as we did previously. So this is 1, 2, 3, 4, 5, 6. And we're gonna say that, let's see, so Q bar 3, 4 will be equal to what? Q sub naught. Q bar 4, 5 will be equal to 250 plus Q sub naught. Q bar 5, 6 will be equal to what? 500 plus Q sub naught. Q bar 6, 1 will be equal to what? 1000 plus Q sub naught. Q bar 1, 2 will be equal to 500 plus Q sub naught. And Q bar 2, 3 will be equal to 250 plus Q sub naught. Okay, that was step 2, no? That was step 3. I guess that's the only thing we did in step 2. So what do we do in step 3? What is it? What do we step 3?
Share flow.
I think that's what we just did. Q sub naught is the assumed shear flow. After doing this, what do we do? The angular what?
Angle of twist equation.
Okay, we did that one before the moment equation. Okay. So what we're gonna here, we're gonna say equate external and internal moments. So basically that should be the equation of summation external should be equal to the summation internal. Yeah, okay. Let's do this right here. Counterclockwise positive, counterclockwise positive. Okay, so here's where Johnny needs two options. Okay, so I want to do both the first time that you can decide what to do. Personally, I like more, but depend on the type of problem. Okay, but personally, I think the first one has more physical meaning. So let's say over here, option 1. We're gonna say take moments about point A, and now I'm gonna tell you where point A is. So basically, if I redo the figure here, one, two, three, 5, 6. Okay. This is point A. All right, so what do we have here? We have, I don't want to talk too much over here. So let's say we are over here. Q bar 1, 2. Q bar 2, 3. Q bar 3, 4. Q bar 4, 5. Q bar 5, 6. Q bar 6, 1. And then remember now for the external, we need to add the force over here, the shear force Vy equal to 10,000 pounds. Then what do we know? That distance here was S. S was equal to what on the initial problem? I think it was 8, no? Is it 8? Yeah, 8. And then we basically know that all the other dimensions are like 10, no? This is 10, this is 10, and this is 10 over here, and this is over here are equal to 5. Obviously, it needs to be equal to 5. Okay, so basically, the equation I'm rewriting is taking summation of moments, external, about point A, equal to the summation of internal moments. Obviously needs to be about the same point, point A, and so on. So this is equivalent. So this stage is equivalent or similar as doing what? Summation of moments equal to 0, okay? So basically we say that if it's statically determined, we should be able to use it with the static equation. Summation of force equal to 0, summation of moments equal to 0. So let's see what happened out here. What is the moment created by the external force? Does it do about point A? Does it do a positive or negative moment? So maybe let me do it symbolically, and then we'll put values. So let's say this is Vy. I think it will be easier. So will this moment create what? Clockwise or counterclockwise about point A? Counterclockwise, so that is positive, no? So what would be the value of the arm? Will be whatever, will be that whole distance over here. So let's say it could be equal to S12 plus S23 minus S. Does that make sense or not? Yeah, it's all that distance minus this one. I rather do it symbolic because that way when you program or you study, you can see exactly what is the meaning. And that's the only external force. Now, we can go around. What will be the moment created by Q12? Q bar 12 will be Q bar 12. Remember, what are the units for the shear flows? Force per unit length. So in order to get the force, you need to multiply this by the length. And now, what will be the arm? What will be the arm? What will be the distance? R. Okay, we can put R. It's not a bad idea. R. Now, we do the same thing for Q23. What are we going to have? Plus bar Q23 times S23 times R. Okay, now do exactly the same thing. We have Q34. So we know Q34. What is the distance on which Q34 is being applied? What is the circumference of a circle? 2 pi r, so half a circle will be pi r. And what will be the arm? R. So start thinking about it. What is pi r squared? Is the area, no? Of a circle. So, okay, what would be half the area? Would be a over 2, no? Something like that. Okay, I mean, let's do it this way. Then we'll do the other one, you will see will be identical. So now let me go to the line because I don't want to talk too much over here. We still have all the bottom ones. Now we have what? Plus Q bar 45 times S 45 times R, correct? Plus Q bar 56 S 56 times R. And now be careful, the last one will be 1 plus Q bar 61 times S 61, but this time what will be the arm? Yeah, will be all that distance, no? Okay, so I like to do symbolic because it's the easiest way for you to study, and also let's say you use MATLAB, which I will highly recommend starting this lecture to start using to do the problems. So what is Vy? What was the value for Vy? We have 10,000. And what will be that distance? Was it 10 or was it 5 that I put? It should be over here 12. 10 plus 10 minus 8, no? This should be equal to what? Now, from the previous figure, what is Q bar 1, 2? What is Q bar 1, 2? Okay, 500, so we're going to put 500 plus Q naught times what? What is the distance? 10, what is the arm? 5, okay? So probably you don't need now me to Z, you do the same thing for Q23. So what is the value of Q bar 23? Perfect. 250 plus Q naught times 10 times 5. Okay. Plus, now we do the Q34. What do you have for Q34? Q naught times pi times 5 square. Now is when sometimes you do the mistake. I mean, that's a place where you do mistakes. Plus what? What is Q45? 250 plus Q naught. Perfect. So this is now where you do the mistake. Times 10. Now what is R? That's a mistake. If you put negative 5, then you reverse the sign of the moment, no? Remember, this is now distances, no? So you need to keep over here the 5. It's not negative 5. We're already taking care of the sign of the moment equation. Then Q56 is perfect. 500 plus Q naught times 10 times 5. And the last one, Q bar 61 is 1000 plus Q naught times pi 5 squared. All right, so if we do here the math, this is going to be, so here, how many unknowns do we have in that equation? 1, no? So we can go and solve. And if you do this, you find that if you want, this gives you equal to minus 323.9.
Professor,
Yeah.
what's the last one have to be pi 5 squared as well? Wouldn't it be just?
Oh, sorry. No. Because I was looking at the value, so this would be, sorry. So it should be S16, which is what, 10, no?
Yeah.
Yeah. Yeah, thank you, sorry. 10, and now the one that will be different will be the arm.
Yeah.
Is it 20, no? 10 plus 10. Thank you. I was just looking at this one.
Yeah.
Okay, so now that we know this, basically what can we do? We can probably go to step 4 over here, which would be our previous procedure, step 5, and we go step 4, which would be what? Basically, Charlie, I like to do 4 steps. Step 4, let's say solve. Probably have 5 on the other one. So solve. Okay, it's not that. Okay, before we do that, sorry for that. We did option. I'm gonna come to this page again, okay? Don't worry about it. We'll get. But we did here option 1. Always if I say option 1 should be an option 2, no? So let's say an option 2 here. Okay, so option 2 is going to be take moments about 0.6 and use the expression we just derived today, m equals to to AQ. Okay, so let's redo the figure. One, two, three, four, five, six. And I'm pretty sure that's the way, from my experience, that's the way, Johnny, is the way you do it in structures one. So this type of problem, I don't know if you did or not, but you have the knowledge to solve in structures one. I don't know if you did or not, but okay. So basically, we do exactly the same thing as before again. So it will be Q bar 1, 2, Q bar 2, 3, Q bar 3, 4, Q bar 4, 5, Q bar 5, 6, Q bar 6, 1. As before, I'm going to put here the force Vy. At a distance S. Okay, so basically what we're doing here is taking summation of moments, external about 0.6 will be equal to the summation of moments internal about 0.6. And we have this. Okay, so I'm going to do another figure here at the bottom that you can do as well. That one will be in support to what we're going to be writing now. One, two, three, four, 6. Okay, so the good thing is that the left-hand side, nothing's going to change. I mean, what will be the moment created by the left-hand side? The external, about 0.6. Will the moment be clockwise or counterclockwise? Clockwise. So that means that will be negative, no? So we have minus Vy times what? S. Okay, now, here we go. If we use this equation here, all right, then what should be the moment created by Q12? We can say here this will be 2A1 Q bar 1, 2, where what will be A1? About 0.6 should be this area over here. And I think that's what you did in structures one, no? All right. Personally, I like more the other one, but sometimes you need to use this one. Okay, you have a choice. All right. Now, what will be the moment created by the Q bar 1, 2? You will have plus. So Q bar, so we have 2, A2, Q bar 2, 3. What should be that area? This one over here, no? Okay, now what will be the okay? Now we go to 3, 4 plus 2A3 Q bar 3, 4. What will be A3? All the rest, no? Okay, and I know this is the way you did it. It's not just one. There's nothing wrong with it, okay? Just that I think you lose some physical meaning. Okay, so in this equation here, what is A1? What would be the area A1? If we do a calculation, should be what equal to what? S16 times S12 divided by 2. So that means 10 times 10 divided by 2, 50. What would be A sub 2? Will be equal to what? S16 times what? S12 plus S23 divided by 2. But what do I need to do next? So I have all this one, no? I need to subtract the A1. So again, this will give you 50 inches squared. And finally, what will be A3? I could do something similar. It should be what? S16 times what? S12 plus S23 divided by 2 plus what? Pi. I'm going to put the, instead of putting the value, I'm going to put the expression pi r squared over 2, no? Half the circle. Plus half a circle, no? It's all this blue here plus half the circle, no? And this is your calculation gives you 139.27 inches squared. Okay, so let's see if I can do it over here. Maybe I have enough space. So this should give you what? Minus 10,000 times 8 equals to 2 times. I'm going to put A1, I mean 2 times 50. You want me to put the value? Okay, 2 times 50. What is Q bar 1, 2? Is it 500 plus Q naught? Okay, I'm not looking, so I'm going to trust you, okay? And then what will be here? 1 plus 2. A2 is 50 as well. What is Q bar 2, 3? Okay, I trust over here. 250. Please somebody double check. Plus 2 times 139.27. What is Q34? Q34 should be Q naught, yeah. Q naught. So basically, again, here what you have, the only unknown is what? Q naught. And if we solve, we should get here, what do we get before? Minus 323.9 pound per inch. Okay, so again, it depends on the problem, but personally, I think this one has a better physical meaning than the other one. Okay, but this one is true that sometimes it's faster, no? Okay. So anyway, step one, step two. So now we can go to the page that I said over here. That's why I was trying to go to the other page, how to use this one. Step four will be solve. So what do we need to solve? So let's see. I'll go back to this page over here to step two. Okay. So from step two, what do we have? We have that Q bar 3, 4 equal to Q naught. So this is going to give you minus 323.9. Q bar for 5 is 250 plus Q naught. So this is going to give you minus 73.9. And let me put the units, pounds per inch, pounds per inch. Q bar 56 is equal to 500 plus Q naught. So that will give you 176.1 pound per inch. Q bar 61 is 1000 plus Q naught. So that will be equal to 676.1 pound per inch. Q bar 12 will be 500 plus Q naught, so will be the same thing as Q56, so 176.1 lb per inch. And missing just Q bar 23 at the end, which is 250 plus Q naught, which should be the same as Q45 minus 73.9 lb per inch. So we do the figure. One, two, three, four, five, six. So what do I get? So let's see. Q34 is minus 223.9. So what does that mean? Does it go from 3 to 4 or from 4 to 3? 4 from 3. So here I can put 323.9. Okay, let me go around. Q45 is it will go from where to where? From 5 to 4. Q56 is positive, so we'll go from 5 to 6. So 176.1. 261 is positive. 676.1. 12 is positive as well. Should be the same as the opposite side, so 176.1. And this one should be negative. The 2, 3, no, if we did it correct, yeah. So 2, 3 should be going from 3 to 2. And should be symmetric with the other one. $73 point. So 1, 2, 3. No, 4. Okay, so let's do a little summary over here. So let's go here. Statically deteriorated, let's say, problems. Okay, that way we make it easy. So what type of problems are this one? This will be the ones that only have one cell. So you can have what type of problem? You can have this type of problem over here. You could have the one we just did this way. And if I remember right, I think this is the one of the assignment. I'm not sure, but I mean, basically you can have something that is one cell, no? Okay? All right. So for this type of problems, we have, how many steps do we have? 4, no? So just remind me of you, we had step 1, step 2, step 3, step 4. So I know step 4 was solve. I think the step 3 was moment equation. Wait, we need to go backwards, so 5, so it should be 6. So okay, correct. So external moment. So equal, we do summation of external moment equal to internal moment. Step 2, what was step 2? Evaluate shear flows. Okay, the Q sub naught equal to whatever, the Q naught plus Q. And step 1, we say, was to calculate the shear flow. No. Step 1, make a cut. Make a cut so we can do the summation of forces. Make a cut so that then we can assume, we say, do the QS equation. Okay, so that's what we did today, no? Okay, so maybe I should have done that before, okay? What did we do the other day? Statically indeterminate problems. Okay, so what would be these ones? Will be all the time, will you have like the one we did the other day? You can have multiple cells, no? So again, we could do the same as before. I mean, you can go to as many stuff as you want. You can imagine you could have this one, no? Would be 2 cells, or let's say, if you want to make it even more complicated, we could have this, whatever. This, and this, okay? So more than one cell. You can have multiple cells. So you want over here, you just put one cell. Multiple cells. So now I don't have the notes from the other day, so you don't have to help me. But I might want to change it. I'm not going to change it. Let's do the same thing. But so basically, statically indeterminate means that you cannot solve only with the summation of forces equal to 0, summation of moments equal to 0. No, you need one extra equation. All right. So what did we do last time? So I'm sure step 1 was make a cut. Okay. Now, step 2 was the same. Evaluate shear flows. Now, I think the other day, obviously it's not a mistake, but maybe my logical step 3 should have been what? I mean, would be for me, I should have done equate external moment to internal moments. But I think that's not what. Let's put it this way. This would be the way to do it now. It doesn't matter if you switch these ones, okay? These two over here. I think is what I did last time. So here there is too many unknowns, not enough equations. So what you need to do, step 4. Here I'm gonna put that. I'm gonna put this in that you can reverse the order if you want. But this is the way I would like you to remember, no? You go up to here, you don't have enough equations to solve for Q sub 0, you need to find additional equations, no? So the additional equation was coming from what? Angle of twist of itself. So remember we have d theta, dz1 will be, let's say, d theta, dz2. If you have multiple sides, if you have more than 2, you can do this, no? Yeah. And step 5 will be solved. Okay? All right, so I'm not have time to start anything, so I guess today we're gonna finish a bit early. We finished 12:30, no? So we're gonna finish 12:25. Any questions? I mean,